review for the Chapter 3 test starts off with just some solving for x equations. In this one, we're going to want to get the x's only onto one side. So we would subtract 3x to both sides. And it would be a 2x now on the left side, minus 4 still over here. And then the only thing remaining on the right side is the 14. And now we can get this x all by itself, starting by adding 4 to both sides to get the 2x alone on the left. The right side becomes 18. And then the final step to get x all alone is divide both sides by 2. And so the final answer would be x equals 9. This problem is very, very similar, except if we want to move a negative 3x from the right side over to the left side so it can combine with this 4x, I gotta add 3x to both sides. So that leaves 10 over here. 4x plus 3x is 7x. And now we subtract 3 because now we start to get the x all alone. We start to get rid of anything that would be crowding the side that x is on. So first we get rid of this plus 3 by doing this. And now we're going to get rid of the 7 by dividing both sides by 7. And once x is by itself, you're done. In number 3, since we have parentheses over there on the left, the first thing we're going to do, always the first thing you check to do, is clearing parentheses by distributing. So 2 times x is 2x. 2 times 7 is 14. And the next thing is to get the x only on one side. So let's subtract this x to the other side. So now over here there's just a 19. 2x minus x becomes 1x, or just x. Bring the 14 down. Then all we have to do is subtract the 14 out of there, but do it to both sides to get x all alone. And the final answer is x equals 5. In number 4, you would notice that the first thing we should do is notice that there are already a couple of like terms that are already together on the same side of the equation. So 5x plus 4x can just combine the way they are. So you should be looking for that kind of stuff. And 5x plus 4x is 9x. And now we fall right into what we've been doing all along and all these steps we've been doing. Like getting x only on one side. Let's move this term away from the right side over to the left side by subtracting 3x from both sides. That leaves 16 over here. And then 9x minus 3x is 6x. And now that x is only on one side, now we can work on getting x all by itself by adding 2 to both sides and then dividing both sides by 6. And ending with x equals 3. 9, 10, and 11 just want you to be able to fill in how many solutions, if you get a false statement, if you get x equals some number, or if you end up with a true statement. When you have a false statement, or later on we're going to see when you have two lines that have 0 points in common, you have 0 solutions. And if you have a situation where you end up with x equals some number, or if you have two lines that have one point in common, the answer is 1. Or if you have a true statement, or if you have two lines that share an infinite number of points in common, then you have an infinite number of solutions. And you just need to flat out know those three facts and scenarios. Number 8 and number 9 says to tell whether each equation has one solution, no solution, or an infinite number of solutions. Justify your answer, so show some work and stuff. So in number 8, the first thing we would do and it's kind of the same song and dance, you just look to get x all by itself on one side of the equation. So you approach it that same way. So the first thing we would do is clear the parentheses with the distributive property. 6 times x is 6x. 6 times 7 is 42. And next we would, let's move this 6x away from that side by subtracting, but you'll notice they cancel out over here as well. So what we're left with, so the x's have totally disappeared. In our efforts to get x all by itself, we've killed it completely. And so what you're left with on the left is just 42, and on the right is just 7. So we have 42 equals 7, which is a statement that's either true or it's false. So does 42 equal 7, or is that a dirty lie? That is false. What that really means is no solution at all when it's false. Number 9, the first thing you would see to do is combine these like terms that are already on the same side. So you get 8x plus 4 equals 8x plus 4. And then when you look to get x all alone on the one side, cancel here, but look, they also cancel out over there. So you're just left with 4 equals 4. So when the x's, again, when the x's totally cancel out completely, what you're left with is either true or false. So 4 equals 4, is that a true statement or a false statement? It's a true statement. Of course 4 equals 4. And when it's a true statement, what does that mean? It means this: an infinite number of solutions. And in fact, to be a little more specific just right now, that means all real numbers are solutions. Changing gears big time. If what you are given are these 4 ordered pairs, x, comma, y, x, comma, y, x, comma, y, well, I think I lost track there, but it was my mouse. But x, comma, y, x, comma, y, x, comma, y, And you need to know, long term here, people, not just this class, the domain means all of the x values in the relation. So all you have to do is make a list of all the x values, -2, 3, 5, and 10. And the range is all of the y values that you have going on. So -1, -6, -8, -13. You don't have to put them in numerical order, but don't be surprised if you take like a multiple choice test and they are put in numerical order. But bottom line for me right now is that the domain is all of the x's, the range is all of the y's. Same thing here, even easier because, my gosh, like if it's in a table form, we've literally like separated the x's and y's into their own columns. So the domain would be everything in column 1, the x column, and the range would be everything in the y column. And if there was any repeats, I don't think there is there? No. But if there was any repeats, you would not have to write, that number twice. Ooh, okay. Circle which of these describes a function. So 12 or 13. Does this describe a function, or does this describe a function? Turns out that this one describes a function. Why? Because there are no repeat x's. That's the key. If there are no repeated x values, then it's a function. And so when we explain why the other one isn't, that's pretty much, that's pretty much the spin we go with, there is a repeat x value of 2, see? So this one was a function because there was no repeat x's. This one was not a function because there were repeated x values, the 2's, okay? Ooh, the next handful of problems on this page. It's probably best if you could memorize all of these basic sketches. If not, if worst comes to worst, you can always make a quick little XY table to get some points, and you could plot the points and then connect the dots. But again, I think it's in your best interest just to memorize that this equation, y equals x, is this basic sketch of a line. And that y equals negative x is this basic sketch of a line. And y equals x squared is this basic U shape. And y equals x to the third is this basic curve shape that goes through the origin, by the way. Just like this U shape has to rest and it sits right on the origin 0, 0, okay? And again, this y equals x cubed shape passes through the origin. Just like these two graphs also pass through the origin. And y equals the absolute value of x is a V shape that sits on the origin right here. And y equals the square root of x is this basic shape looking graph, which starts out of thin air on the origin. All right? Now, it's this graph right here that's actually going to be for bonus points. So you need to know this guy, and all the other ones. But if you know the basic graph of y equals 1 over x, it'll be worth some bonus points on this test. And the first thing I want you to actually write in on the test is this horizontal dashed line and this vertical dashed line, which are asymptotes. And the rest of the graph goes like this. Just like that. Where it would kind of like creep closer and closer to the axes, but never touch them. And so this full, everything in red here, is what you need for full bonus points for the y equals 1 over x graph. But just memorize all those. because they're going to be the exact same equations I want graphs for on the test. Number 21 here, complete the table. So all these different numbers for x you're going to plug in separately to get each corresponding y value. So when you plug in -3 in for x and you square this negative correctly, -3 squared with the parentheses is +9 minus 2 to get 7. Alright? So again, you're just going to be like plugging in all of these different numbers for x separately to get each separate answer for y that goes with it, like so. And so again, -2 squared is +4. Minus 2 would get you a final y value of 2, and then so on and so forth. And so what you've done is you've generated, let's see, 1, 2, 3, 4, 5, 6, 7 solutions. This pair of numbers together makes a solution. This pair of numbers together makes a solution. This pair is a solution. This pair is a solution. All the pairs are solutions. So there's 7 solutions total, and each one of these solutions is a point on the graph. -3, 7, right here. -2, 2, right here. -1, -1, right here. 0, -2, right here. And so on, and so on, and so on. And so you plot these dots correctly, and then I want you to connect the dots. In this case, it was a U-shaped parabola for your final graph. Ooh. In number 22, what you're given is a fully completed table, well, of 7 points anyway, 7 ordered pairs. And you need to come up with like the equation that corresponds with that table. Function rule means equation. So what is y going to equal? Okay, like how could a -3 become a 2, and -2 become a 3, and -1 become a 4, right? Better yet, maybe you look down here. How do we make a 0 into a 5, 1 into a 6, 2 into a 7, 3 into an 8, right? Like you might think, like it's possible, your first idea was, I don't know how possible, but it's possible that you look down here at the 1, 6 and was like, if I multiply this x by 6, I get that. So is that the pattern? Do I always multiply the x by 6 to get the y? But then you look at this one and go, wait, no. That multiplying by 6 pattern doesn't hold for like any of the other pairs. So how else can you turn a 1 into a 6? What other operations are there? Well, there's adding. So what could you add to the 1 to make it into a 6? Couldn't you add 5? All right, so maybe the pattern is we always add 5 to the x number to get the y number. Does that hold true for 2 becoming a 7? Yep. Does that hold true for 3 becoming an 8? Yep. Does that hold true for 0 becoming a 5? Yep. -1 to 4? Yep. -2 to 3? Yep. -3 plus 5 equals 2? Yep. And so that means that the equation is that y will always equal the x number plus 5. Last couple. Changing gears a little bit, we're going to be now solving for y, which means just get y by itself. All right? So is y by itself over here on the left? Nope. -7 right there. How do we get rid of this -7? We add 7 to both sides. So that'll get y by itself, right? What does the right side become? Can we do 3/4 x plus 7? Did those mix together as like terms? No, they do not. So what this becomes over here is just these two terms are going to be, they're going to remain separate because you're not going to mix them together. They're not like terms. You can't do 3/4 x plus 7. So the right side is just going to be 3/4 x plus 7. You have to leave them as separate terms over here on the right side. And, hey, just like solving for x, whenever you solve for y, whenever you're at the spot where you've gotten y all by itself, you're done. You stop. And so this is the final answer. This problem is y by itself. Nope. We got to get rid of the 7. How do we get rid of that 7 in this situation? We divide both sides by 7. And so how do we divide that right side by 7? I'll tell you how. You have to divide both of those terms. Both of those terms by 7. So 3x divided by 7. Let's specifically 3 divided by 7. The x is just going to be along for the ride. So can we do 3 divided by 7 cleanly? No. So it's going to be a fraction, 3/7. Can we at least reduce that fraction of 3/7? No, we can't even reduce it. So y is going to be alone on the left, I guess. And we're going to have 3/7x. But don't forget, we also have to divide the 14 by 7. Is that clean division? Yep, that's just 2. And again, just as soon as you have y alone, you're done. Well, in number 25, final problem, in order to get y by itself, there's going to be this that has to get out of there, as well as the 3. So the first thing we get rid of is the entire separate 4x term by subtracting it from both sides. So we get rid of this entire 4x term first. That will leave 3y alone on the left. And when you look at over here, negative 15 minus 4x, just like an earlier problem, those do not mix together. They are not like terms. They do not combine. All right? Now, what I would like you to do is put this term first. If you were to have negative 15 minus 4x instead, I wouldn't mark you wrong, but as we think about what we're going to be doing in the near future, I would like you to put the x term first and then the regular number. So, and then, well, the final step would be to what? How do we finish getting y by itself? How do we get rid of that 3? We divide both sides by 3. So, I don't like that. I'll just use the pen and not the mouse. So y is going to be by itself. And then over here, don't forget that when you divide both sides by whatever, you're going to be dividing both of these terms by 3. This division is not clean. You can't even reduce that fraction at all. So you get this. You would reduce if you could. But so we'll just have negative 4/3 x. Don't forget about the x. And then minus 15 divided by 3 is minus 5. And that would be the final answer for number 25. Happy studying. Thanks, Mozart.